All right, this is like part 4 or so. I'm actually losing track, but I'm guessing that it's part 4 of our lesson reviewing graphing rational functions. Okay, we're picking up here with number 7, where we're going to actually get to graph this rational function. Let's zoom in. All right, on number 7, we have to graph this, and we need to talk about transformations. Let's talk about transformations first. And when I ask you transformations, I want to know, compared to the parent function, and by the way, the parent function would be like this. 1 over x, that's the parent function. So compared to that, this function has, let's see, 1, 2, 3, 4 transformations on it. 4. See if you can get them all. Okay, let me point arrows to them. So for example, this -1 here on the end, that's a transformation. What's that doing? That's moving the graph down 1. So down 1 is our first transformation. Okay, so you just simply write that down. Down 1. Okay, let me change colors when I do this. Okay, the x minus 1 there. What's that -1 doing?
Left, right one.
Yeah, this inside the function is left or right, but it's the opposite of what you would usually think. So this -1 is actually a shift to the right 1. Okay, so that's our second transformation. Right 1. Okay, I said that there were 2 more transformations. What am I talking about? Yeah, well, I'm going to split it up, okay? The 2 part, okay, without the negative sign. What is the 2 doing? Anyone remember this from before? Stretch. Vertical stretch by a factor of 2. You have to write down that entire thing. Vertical stretch by a factor of 2. Okay, and what about the negative sign in the front? That's a reflection over the x-axis.
Do we have to put both of those?
Yep.
So it's a reflectional stretch that moves down 1 and right.
Yeah, just list them all. Okay, so you have to list all 4 of those things. That's what I mean by transformation. Okay. All right, so now we've got to go on with the rest of this information. Let's actually start with the asymptotes next. Okay, vertical and horizontal asymptotes. Look, when you have a function that's in this form, that's just a transformation from that parent function, the shortcut is this number hanging off the end right there, that's going to be my horizontal asymptote. So this is going to be the horizontal asymptote right there. So that's one way to think of it. Oh, we got a little -1 there. That means we're going to have that horizontal asymptote is going to be y equals 1. All right, don't forget to put y equals 1 in front of it. Another way to think about it is all of the other types of problems that we've done, they don't have like a extra number on the end. It's just a fraction like this. So normally when we talk about horizontal asymptotes, we're talking about the degree, okay? And is the degree higher or lower in the top than the bottom? So it's just scribbling out that -1 for a second. You would think of it as, look, the top degree is less. The top degree is less, okay? Because it's degree 0 and degree 1. So what's normally the asymptote? What's usually the horizontal asymptote when the top degree is less?
0.
That's when it's usually 0. So normally the horizontal asymptote would be y equals 0, okay? That would be right here on the x-axis. I'm going to go ahead and draw that real quick. Okay, this is thinking of it as a transformation. Okay, so normally it would be right here at y equals 0. But, like you said when I asked you about those transformations, putting a -1 on a graph moves the graph down by 1. So that's going to affect the horizontal asymptote and take it from 0 down to -1. All right? So that's the other way to think about it. But either way, you have a horizontal asymptote. Did I say 1 before?
Yes.
I didn't mean to say that. Either way, the horizontal asymptote will be y equals -1. -1. Okay? Now, the vertical asymptote is going to work the same way as always. So where do I get the vertical asymptote from? The denominator, setting that equal to 0. So if I do x minus 1 equals 0, add 1 to both sides, that's going to give me x equals 1. That's my vertical asymptote. Okay, x equals +1. All right, let me see if I can. This is going to bother me. So slow. Okay, so I have my two asymptotes. All right, we should be able to do the domain right now, just based on this alone. Okay, because the domain is just going to be split by the vertical asymptote. That's all. So regardless of exactly how the graph works out, the domain is going to be from -infinity to the asymptote, and then from the asymptote to +infinity, left to right. So the asymptote's at 1, so that means my domain, even without a graph, is going to be -infinity to 1, union 1 to infinity. Okay? All right? I'll do the range after we graph some points. Now, the X-Intercept. How do we find the X-Intercept in general? Yeah, normally we set the numerator equal to 0, don't we? But on this one, on this type where it's a transformation of the graph 1 over x with this extra stuff on it, this is the one time that we can't really do that. Okay? This is the one time that we have to go ahead and set the entire graph, the entire function equal to 0. And solve that. So here's what I mean. So if I want to find the X-intercept, okay, graphs like this, this is the one time I have to just go, okay, 0 equals -2 over x minus 1 minus 1, and solve this. Okay? So I would add 1 to both sides, for example. So that's going to give me 1 equals -2 over x minus 1. Okay? I would multiply it by x minus 1 on both sides. So x minus 1 on the right and x minus 1 on the left. We're looking for the x-intercepts. So that'll give me x minus 1, and these are canceling out. So that gives me x minus 1 is equal to -2. Yes, sir. So that's going to give me x equals -1. So this is going to give me my x-intercept. Since that's my x-intercept, I'm going to put this as my x value. Okay, so x-intercept. So I'm going to put -1 for my x value, which means the y value is automatically 0. Okay, and now for the y-intercept is much easier. How do I find the y-intercept? Right, I let x equal 0. I plug in 0 for all the x's. And that's how I get the y-intercept. Okay, so for the y-intercept, I really don't have to do any work. I just look and see, okay, there will be a 0 here where the x was. Okay, so it's like that's gone. So that just leaves this stuff right here. -2 over -1 minus 1. Now, if you need a calculator for this, I'm not going to laugh at you exactly because that would be hurtful. But you shouldn't need a calculator for this. Because what's -2 divided by -1? 2. Right, yeah, that's +2. So it's just 2 minus 1. Okay? So that's just going to be 1. Yeah. What if I got that wrong right then after like teasing anybody that needed a calculator? That would have been humiliating. So what I say? 1. Okay. So the y-intercept is 1. Because it's the y-intercept, I need to put it at 1. Okay. And the x value is 0. All right, it's almost time to make the table of values. Let's go ahead and graph the 2 points that we have. So I have -1, comma 0 is a point. So let's plot that. So x-intercept -1, comma 0. We have that point right there.
Error at 1.
And then 0, comma 1 is our y-intercept. So we have those 2 points right there. Okay, that's almost enough right there for us to graph this left branch. Okay. We should get a couple more points though, just for fun. So let's see. Let's put this in our calculator. Okay, so in the calculator, so it's -2. Help me remember this function. Do you have it in your head? Well, it's on your paper also. All right, wait, I'm not ready. No. Okay, so what I hear you saying is
-2.
-2 over
X minus 1. Minus 1.
Okay. So let's do a couple points here. Let's see, where do I want to start off at? You know what, I'm gonna do ask mode actually. All right, because I only need a few points. I'm gonna do ask mode so I can get my decimal on. Yeah, well, you don't have to, but sometimes it'll mess you up with not having them. Trust me. Okay. So for example, I'd like to see what's going on at -2. I'm gonna do that one. So I'll do -2. Let's see. So -2 is -1/3. Okay, so I can graph that easily. So -2 is -1/3, so that would be like here. And I'm going to do the decimal, so 0.5. I'm going to see what's going on at positive 0.5. Oh, it's already there, 0.5 from another problem. So 0.5 is 3. Okay, so at 0.5, I'm at 3. Okay, so that's plenty of values for me to graph the left branch. So this must be doing like this right here.
Do we have to draw a chart?
I don't know. Did they say anything about the chart?
Don't mess up. No. I like that.
Yeah, it's not too bad. It's not too bad. You know, sometimes I make a chart for you, and I'm like, fill this in, or sometimes I'll be like, make a chart, people. But if I don't say anything at all, then.
What if it helps you?
Well, I mean, you know, I'm not gonna stop. You can always do it on scratch paper. I'm not gonna stop you.
I'm just making sure. You can't make a chart.
All right, no charts. -1 if you have a chart. Whoa. Okay. And let's see. So while I'm at it, let me check out 1.5 because you know I want that decimal. So I'm going to check out 1.5. 1.5. Okay, at 1.5, I'm at -5. So that would be like her.
3.
Okay. And I'm going to check out 2 and 3. Okay, so 2 and 3. All right, so at 2, I'm at -3 and -2. So I'm at -3 and -2. All right, so that'll be enough values for me to see what the deal is. So it must be like this. Yeah, I definitely messed that up. But I'm not going to fix it. I don't have time for that. That's even worse. Now I got to fix it. Okay, so the range is possible now. So we do the range from bottom to top. All y values are covered except for we have to hop over this horizontal asymptote. So it's going to be similar to the domain. It'll be -infinity to -1. And then -1 to positive infinity. That'll be my range.
Range is going to be what?
Okay, -infinity to negative 1.
Box.
Negative goes right here. Because these, this time it's an asymptote. So we can't touch the asymptote, so we're going to leave it round because you can't reach the asymptote. Okay?
Why is that?
Because that was the horizontal asymptote.
So when do we touch?
All right, let's go ahead and do the increasing and decreasing intervals now. That's what that stands for. So, look, the first branch, the entire first branch is increasing, all right? Because from left to right, it's going uphill. So, so that's from negative infinity to 1, because we're just doing x values. So, x value wise, I'm talking the x value of this end is negative infinity. Okay, the x value of this end is 1, not infinity. Does everybody understand why the x value of this side is 1?
No.
Asymptote.
Oh yeah.
Okay.
From left to right.
Right, correct. We're reading it from left to right. Hold on, let me yell at my... So that's why we'll do negative infinity to 1 for the increasing part. Okay. What about the other branch? Is this increasing or decreasing? That's also increasing. It's going up, 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 up. Okay. From left to right, it's going uphill. What's the x value of this end right here? That's 1, not negative infinity. Do you guys see that? X value of 1. What about over here?
Infinity.
That's infinity. X values of this branch are from 1 to infinity. Okay? Okay, so it's basically just like the domain was.
So there's no decreasing.
There is no decreasing part. Okay? Increasing, decreasing intervals always use round parentheses anyway. All right, now end behavior. As x approaches negative infinity, the function approaches. This means on the left. Okay? What is the graph approaching on the left? It's close. Negative 1. All right? On the left, this graph is approaching the horizontal asymptote. Pretty much, if there's a horizontal asymptote, that's going to be your end behavior every single time. Okay? So on the left, it's approaching negative 1. Guess what? On the right, what's happening?
It's approaching positive 1. Negative 1.
It's still the same asymptote, right? So it's going to be approaching negative 1 on the left and the right. And really, anytime that you got a horizontal asymptote, that's what's going to happen. Let me just write that down, then we'll take that question, big dog. So as x approaches positive infinity, f of x also approaches negative 1. All right, this video is long enough, so I'm going to go ahead and stop this video here. But I'll pick up the next video with number 8. See you on the next video.
Okay.
Adios.